All right, last little bit, kind of tying it back in with what you guys were talking or looking at yesterday. Logarithms and their inverses. A logarithmic function is the inverse of the exponent. So this is also, or an example of that would be, if f of x equals 2 to the x, then the inverse of that, f inverse of x, is equal to log base 2 of x. Now we're going to do kind of similar to what you guys were doing in the notes yesterday. Using x equals -3, -2, 0, 1, and 2, we're going to graph the function f of x equals 3 to the x, and we're going to graph its inverse based off those points. So I'm going to draw a line here because we're going to have to draw or come up with two different tables. So one of them we're going to have f of x equals 3 to the x, and then we'll make up the other one in a little bit. So making a quick table out of this, we're going to plug in the x values that they suggest. So -3, -2, 0, 1, and 2. I don't know why I skipped a -1, but I did. So plug in a -3. 3 to the -3rd power, again, just kind of working through this space. 3 to the -3rd power is the same as 1 over 3 to the 3rd, which is 1 over 27. Plug in a -2, you do the same route, you end up with 1/9. 3 to the 0 is always 1. 3 to the first is 3. 3 to the second is 9. And we're going to plot those points as best we can. So on our graph, we'll go to -3, 1/27. Folks, that is a stupid small number, so we're just going to put it really close to or y equals 0. Then for -2, 1/9, that's also pretty darn small, but we're just going to try to put it a little higher. At 0, we're up at 1. At 1, we're at 3. At 2, we're up at 9. And so we're going to draw a nice smooth curve connecting these. And that's one of those exponential graphs we were looking at earlier. Now try to make it, and I didn't do a very good job of that, but try to make it so that the left part of that graph is getting closer and closer to the x-axis. Now the inverse of that, I'm going to do that in red. So we're going to say f inverse of x would be log base 3 of x. Now just like you did in the notes yesterday, you're just going to swap the x and the y values. So you've got x values and you got y values. We're going to take the 3 or -3, 1/27th, and we're going to flip that around. We're going to make it 1/27th as our x value, -3. Instead of -2, 1/9, we're going to make it 1/9, -2. Instead of 0, 1, we got 1, 0. Instead of 3 or 1, 3, we have 3, 1. Instead of 2, 9, we got 9, 2. And so we're going to plot those points. So 1/27th, -3 is, we're going to say it's about there, pretty close to x equals 0. Or sorry, yeah, pretty close to x equals 0. 1/9, -2, it's also still pretty close. 1, 0, we got it over there. 3, 1, and then 9, 2. And we're going to draw a nice smooth curve there as well. And so for this one, try to draw it really, really close to that y-axis. Now we're asked to describe the domain and range of that red graph. So I'm going to say domain, which as always is describing the x values. Those are elements of the real numbers. Well, before we do that, let's actually talk to the domain and range of our exponential function first. The domain on the blue graph is the x values, and we can plug in whatever x values we want. The range on the blue graph, on our exponential graph, again, y is an element of the reals, but as we were looking at earlier, y has to be greater than 0. It's never going to be able to hit y equals 0. Now for the domain of the inverse, remember you flip-flop the x and the y for domain and range, or from a function to its inverse. So we're going to do the same thing for its domain and range. So our domain becomes our range and vice versa. So we're going to say x is an element of the reals as long as x is greater than 0. As you can kind of see on the graph, that red curve is getting really, really close to x equals 0, but never quite get there. And the range, in this case, it looks like it goes forever up and forever down, so we're just going to say y is an element of the reals, and that's it. Any real number will work there. Folks, I'm hoping to be back tomorrow. Sorry I'm not feeling so great still, but I will see you soon. There's no homework tonight, so have a good one.